Welcome to Jimbo's Garage.
Good afternoon, everyone. Welcome back to Jimbo's Garage. Well, today I've got what I think is a pretty good video. One of my friends is a local farrier here in town. In case you don't know what a farrier is, it's a horseshoer. Well, they've got a series of tools that they use on a daily basis. One of them is an anvil. This particular anvil that he has is 125 pounds, and currently he's taking it out every day, putting it on an anvil stand, and he was asking me if there was any way that I could help him design some sort of a stand that would be able to, that he could put his anvil on, that he could pivot it under the body of the truck and then swing it out when he needs it. And I thought that'd be a pretty interesting little project. So let's see what we can come up with. Let's get started on today's video. Alright, so what I'm doing is I'm getting started here with some 2.5-inch square tube, and this is 3/16 wall thickness or 288. You know, this is just something that, you know, it's a design build. I'm just designing it and building it as I go here, trying to figure out what the best solution is. I had a plan in the back of my head, and I'm kind of staying with it. And I think what I've got going here is probably going to work. There's not a lot to this component right here. Basically, it's like an L frame. We're going to have a long leg that the actual anvil is going to be mounted to on a flat plate, and then a riser part that's going to be mounted to the chassis of the truck. So in terms of the square tube, that's just about all we have right here is two pieces. Alright, I've made a couple of cuts to the 2.5-inch square tubing, and I've assembled some material here, what it's going to take to build this project. Now, you know, I want to point something out. You know, it's always important, or at least it is for me, that every project I do, I hang on to all my drops, all my small pieces from everything, all the projects that I do, I hang on to everything as much as I can. You never know where you're going to use it. For example, I got a 4-inch by 1/4-inch thick round. I had 5 or 6 of these left over from a project. I hung on to all these, and we're going to be able to use this in the project, as well as this piece of 3/8 by 3-inch round. This has got about a 1/2-inch hole drilled through it. We're going to weld this up and be able to use this, and a whole bunch of other miscellaneous all thread and 1/4-inch plate and 1/2-inch plate and some square tubing. We're not going to use all of this stuff, but we're going to use some of all of this stuff to cobble together this anvil stand. So let's get to building. Alright, so the assembly part, you can see the two pieces right there, but before I go ahead and weld that vertical piece on, I've got a lot of work to do right here. And this right here is going to be part of the swivel base that the anvil is going to be sitting on. One piece of this is like 4-inch tube. You can see it's like a 1/2-inch thick wall thickness there. I'm not certain, but I think that's what it is. It's pretty thick, and that's going to be welded to the long part of the arm of the frame. And then I've got a piece of like 3-inch tube that's like 1/4-inch wall thickness, and that's what I'll be cutting out here in a second. And that is what's going to be going on the inside of that, and it's going to be able to swivel around. At least that's my plan anyway. That's what I was hoping is going to work. So I need to get over to the lathe and do a little bit of lathe work, something I don't do a lot of, but you know, it's kind of fun. I do enjoy dabbling on the lathe a little bit and testing my skills, my machining ability, which isn't the best, but hey, it works. So I just need to deburr the outside of this piece right here and kind of clean it up and trim it up. Sorry for the out of focusness right there. You know, the lathe's got a light on it, and it just interferes with the focusing here. So the first thing I need to do is turn the smaller piece down to the inside diameter of the larger piece. This is what's going to slip on the inside, and this here is the larger piece. And you can see that's a tight fit on the inside, and that's what I was hoping for right there. So being a tight fit, there's going to be a lot of friction in there, and I thought it'd be a good idea to add a grease zerk. And so that's what I'm doing right here on the larger piece. And then while I'm also at it, this is the actual size for the grease zerk, and then I'm actually going to use this as a pilot hole for a 1/2-13 that I'm going to be drilling and tapping as well, and that's going to be on the other side. So I got a couple of holes right here with a smaller size. So actually I'm using a number 7 right here. That's what's used for a 1/4 inch tap. And I'm just using this as a pilot hole for the 1/13 as well. All right, and this is the fractional size I need for the 1/13. I'm not certain what it is. It's a little bit smaller than half. You know, I got this drilling milling machine, and it's been serving me pretty well so far. I don't have too many complaints. All right, and then this is the 1/4 28, I believe, is the size for the grease zerk, and I'm just tapping that, and then I'm just going to flip this over and tap the 1/13 for the locking mechanism, or the locking bolt I'm going to be making a little bit later. And that works pretty good. And that 1/13 gets in and out of there pretty good. Just cleaned it up, and that spins right in. All right, so this is some 1/4 inch flat plate, and I've made a template out of some 1/4 inch plywood right here, and this is what's going to go on the vertical part and the horizontal part of the frame. Now I didn't want to have just a straight 45 piece down, so I kind of came up with this little bit of a S pattern. This is going to work the way I was hoping, plus it's going to allow a little bit of space for the horn of the anvil to actually fit in there as well. And then while I'm at it, I've got a couple of tabs I'm going to cut out. I got to say, the 875 SC has been working pretty good. I don't know if you guys have never had a plasma cutter before, man. I'm telling you, these things. I know, you know, the flame torch or flame cutting is the way they used to do it, and that still works well. But I'm telling you what, these plasma cutters, man, they make quick and easy work out of just about any material you're cutting. All right, just going to smooth things up a little bit here with a flap disc. I'm just going to go around. It didn't have too much to do. It was pretty clean cut. The template was pretty nice, so I'm just kind of cleaning up some rough edges right here and rounding over and getting everything nice and smooth. Last thing I want to do is have any sharp edges on something like this. Okay, so I got just about all the parts put together, pre-cut, and ready to start assembling. The one thing is we're going to make a little bit of a modification. On my original plans, I had a leg that was going to be able to swing down from the bottom and support the weight on the very end of this when it's out in position. And it was going to swing up and attach to this, and I got thinking about it, and that's going to be a little bit too, I don't want to say complicated, but a little bit too much for the outside. I want to utilize the inside of the tube right here, and so that's what we're going to do. I'm going to make something that slides inside this tube for traveling, and then be able to pull out and attach it to the outside. It's much more cleaner that way and much more efficient. So what we need to do is we got to drill some holes in this tube before I get everything all tacked and welded together. It's going to be much easier. We'll also build this leg and get it done, and then finally we'll be able to start assembling everything. So let's do it. Okay, this is why it's important to hang on to a lot of your scrap pieces or your drop pieces of all different sizes. You can see I got a little bit of everything here. You just never know when you're going to need that little part or that piece that's going to work for your project. What I'm looking for right now is a piece of 2-inch square tube that's at least at 0.95 or a 1/8 thick wall thickness. That's going to be able to slide inside the 2.5-inch square tube that I'm working with over there for this fold down leg that I'm looking to assemble. So I see this piece of 2-inch square tube. This is a 1/4 inch wall thickness right here. I don't like the way it's rounded, and it's a little bit too heavy duty for me. And so I chose not to do that. I do have some other 2-inch down here, but look what I found. I need a piece 10 inches long. Check this out. This is a piece of 2-inch 095 square tube, just what I'm looking for, and it is exactly 10 inches long. What are the odds? Perfect. Okay, so I just want to show you my setup right here. So I'm over at the ZX45, my mill, and I've got the 2.5-inch square tube cranked down. It's Kurt Weiss. I've got a 1/2-inch hole that I need to drill out here on the very end, and then I've got a 3/8 hole that I need to drill through this direction here at about the 8-inch mark in. So this is a pretty long piece, almost 40 inches. So I've got it cranked down here. I've got it supported by a Brown & Sharp screw jack on this end for some support. I'm going to go ahead and use a pilot hole. I'm going to use a 1/4-inch pilot hole, and then I'm going to change out to a 1/2 inch, and I'll get the 3/8 hole drilled. All right, let's get this done. You know, trying to think everything through thoroughly. That's why I'm trying to get a little bit ahead of the game right here. And, you know, again, there's a lot of work to do on this piece right here before I weld that vertical piece up. This is what I'm talking about. I got some holes to drill and a couple other things to do. And I couldn't imagine having that other part, the vertical part of this frame, twisting it all around, all over the place, trying to work with that. That's going to come a little bit later. We need to get all this other stuff done first. These Champion twist wheels are something new to me, and I'm telling you what, they're razor blade sharp. As long as you keep some lubricant on them, these things cut and drill like I've never seen before. There's nothing like quality. You know, you can get all kinds of drill bits places, and I'm guilty of that. I just go and get some anywhere and use them, whether it be from the Home Depot, the big box store. That's all fine. They all work pretty good for the first couple cuts, but boy, I tell you, quality, nothing beats quality. All right, so this is part of the, I want to say, leg at the end of the long horizontal piece that's actually going to support the weight of the anvil. When the anvil's sitting on there, it's going to be sticking out there about 32 or 36 inches. I can't really remember. And, you know, it'd be nice to be able to have something solid underneath that can support that. And this is going to be part of the design that I have for that. Really complicated, you know. Those, you know, this is just something I'm coming up with as I go along right here, and I don't know. There's probably all kinds of different ways of doing it, but this is what I thought of, and I'm hoping it's going to work. Taking a lot of time to get everything nice and plumb and nice and true right here. This is going to be spinning on the inside. You know, you go to all this trouble a lot and try to get everything perfect, but you know, as soon as you put some heat to it, it always seems to move around a little bit. I'm constantly checking to be sure it's plumb. All right, so I got that piece, and so now it's just a series of real complicated small stuff to do right here. You can see I got some square tube, a couple of nuts. You know, we're going to weld those two together, and you can see that I'm holding that nut down there for a reason, and this one on the inside for a reason. There's reasons for everything doing it the way I'm doing. You'll see as I go along here. You know, sometimes you jump the gun a little bit. I do. You know, I'm trying to busy filming at the same time. I'm thinking about building things, and I'm worried about getting the camera where it needs to be, and I just started drilling holes, and you'll see a little bit later on. I made a little bit of a mistake, but it's nothing we can't fix. Small, intricate little pieces, I'm telling you. It's definitely not something that you can buy at the local hardware store. You gotta. This is just something that I'm trying to piece together here. Cool little fabrication clamps, I'm telling you. Tools of the trade. Got some nice stuff. It really works well. All right, so this is going to fit on the end right here. and I'm going to hold that down, and I'm holding it down for a reason. I don't want any of this weld to be sticking above this part right here, so that's why I held it down about 1/4 of an inch so I could get a weld on the inside of it. And then this piece screws onto this, and then this jams in tight. And then I'm going to go ahead and tape the threads. This is a little trick, I don't know, maybe not a trick, but obviously when you're doing some welding around some threads and you don't want to hurt the threads, get some protection on there. I just use some tape right here, and as soon as I get done right here, you know, you definitely don't want any spatter on there, and it screws in there pretty good. All right, so that's the idea there, and you can see that's the mistake I made. That hole is supposed to be on the other side, but no worries. I'm just going to fill it in right here and do the same on the other side. And then during the cleanup process, which I'm going to grind things down a little bit, kind of soften up the edges, I'll just grind that weld down. Do the same on the other side right here. Re-drill the hole, this time in the right spot. And this is the way this assembly works. You got the long tube. This goes inside. It's held together with a pin or a bolt. In this case, it's a bolt. You pull it out, put the thread up through the bottom, adjust the bottom screw down until it hits the ground, and then that is technically the idea on how it's supposed to work. Trying to keep everything consolidated, utilize the tube that I have on the end right there, and I'm hoping that that does the job right there. All right, so now it's time to start assembling the base here that the actual anvil is going to be sitting on. I've got all the machining done that I need to get done to this point right here, and it's just kind of critical that everything is right in the center. Trying to get everything where I need it to be. And I want to just tack everything in place. This is, you know, I don't want to start doing any kind of welding all the way around right now. I want to be sure that everything is going to fit the way it's supposed to fit, and be sure that it's going to be right before I do any final welding right here. This is the support brackets on the underneath side. I'm thinking this is going to provide some support for any kind of download. All right, with that in place, everything's still working pretty good. Now it's time to cut out the plate. Now this is something that I haven't done before on my plasma cutter. Now this is a 1/2 inch thick plate. I have never cut this thick before, and this is, I want to say it's about 9 inches by 11 inches is what it is. And this is just the plate the anvil is going to be sitting on, and this plate is going to be welded to that 3-inch round cylinder. And you can just check this cut out right here. I mean, you know, I cut a lot of 1/8 inch and you know, a fair amount of 1/4 inch, but this 1/2 inch, this cut was so clean that I barely had to do anything to it. There was very little dross. It was a very clean cut. I just used a flap disc very lightly around the outside edges. The only problem I had right here is right where the burn-in was. Even that really wasn't too big of a problem. I just gave a little tap right here with the hammer, and it just kind of lifted out outside of that little burn-in on the bottom right there. In terms of the cut, it was very clean, and there's very little dross on there. You can see that right there. I just took a little chisel, just knocked it off, and then just a little flap disc to go around the edges to clean everything up. All right, then this is some 1.5 by 1/4 inch flat bar stock, and I'm going to be putting this around the outside edge of that plate, and that's what's going to kind of hold the anvil in place. The anvil's got a 1-inch standoff base to it on the bottom, And this is it's a pretty tight fit. It's going to fit right in there, and it's going to be nice and snug, and that's how that anvil is going to be held in right there. I will be putting a couple of brackets over the top of the base of the anvil to kind of secure it in place. We'll do that a little bit later on. Double checking my measurements to be sure that I'm right on the money right here. Now, one thing I don't want to do, because it's such a tight fit, is I don't want to do any kind of welding on the inside. I am going to put just a little bump in each corner. The anvil itself has a little bit, the edges, the corners are slightly rounded, so there's no problem for that on those inside corners. But I'm going to do all the welding to the outside right here. All right, so one thing about this right here, if I didn't tell you, you would never know. Sorry about all that overexposure right there. But I grabbed the ProPulse 200, which I had spooled with some 309L dual shield flux core, and I didn't know that's what I had on there. But I started welding, and I realized there's something wrong with the material I was using, and that's what it was. But I just went with it. It didn't matter. That's not the prettiest of welds, but it doesn't matter. I'm going to grind it down anyway, but it was definitely different welding that 309L to this mild steel. But I'm telling you one thing, it sure was hard. It took a little bit for me to grind all this down right here. All right, well, with the plate done, now it's time to get the cylinder welded on. Critical that this thing is right dead center. You might have seen that I had already got a scribe mark in there, and I've done my math, and everything is right on the money. It's just a matter of getting everything held down securely. And my whole fear with this whole thing, especially this part of the deal was, I'm concerned about, a lot of heat going into this, especially when I start welding this thing all the way around. Is it going to start distorting? Is it going to warp? Is it going to get out of round? All that stuff came into mind doing all this. And surprisingly, it did a little bit. I had to actually do a little bit of file work and a little bit of emery paper, but outside of that, it was all pretty good, especially after all this welding was done. All right, so I'm just welding the base around here. Funny thing here is I wanted to get a little weld on the inside right here, and I couldn't get my gun in there on the right angle. So I broke out the Anvil Arc 200 TLP with a little bit of stick welding action, and just took care of that all the way around the inside. There's a lot of weight on this. I definitely don't want anything breaking. All right, we got that. I'm going to set it aside, and I'm just going to go ahead and finish the welding out on this part of the brace right here, this part of the swivel plate. Yeah, you can see where I had concerns about getting that around or getting old or getting any kind of distortion going on. You can imagine all the heat that's taking place during this welding, where I'm going to the front side right here, then I'm going to flip it around the other side and get the back side. But everything worked out pretty good. Before I go ahead and just weld everything together here, I'm just getting everything fixtured in. You can see my table dogs right there. Everything is always at a perfect 90 degree, especially in the welding table right here. Once everything is clamped down, just putting a little tack in here. Same on the other side. Just want to kind of hold everything in place. Now comes the plate, and I want to get it tacked in before I do any final welding. Trying to keep everything nice and plumb, trying to keep everything nice and straight. There's a lot going on right here. I saw a lot of weld coming up here and a lot of material. I just want it all right. All right. You can see it was a little sticky right there, but I was able to get that out. All right, so there's a lot of continuous welding right here. You can see I'm using this this product from CRC. It's from their Weld Aid line. It's Weld Clean 350. It's an anti-spatter. This stuff works pretty good. Especially, I don't want any spatter on here. It does help. I use 90-10 for my shielding gas, 90% argon, 10% CO2. That helps reduce a little bit of that as well. But this Weld Clean 350 works pretty good. I got it on Amazon. You might even be able to find it on their website, CRC's website. You can see me fiddling around with my nozzle right here because it's you get a lot of buildup when you're doing a lot of continuous welding like this. You do get a considerable amount of buildup, and I don't know why I didn't do it earlier, but you can see me still farting around with it, cleaning it out. I think it's someplace right in about here. I just grabbed for the nozzle dip. I should have done that before I even got started. Yeah, there I am. A little bit, almost too late. This stuff works pretty good though. You put that in there, one little dip, and man, that'll keep your nozzle clean for a long time. Again, that's a Weld Aid product. I got them both on Amazon. Just little tricks of the trade. Just a couple of things. Always, it's nice to have stuff in the shop. You can see how clean it is. You can see there's no spatter on there. All right, this is that handle I was talking about. I keep all these wrenches. I go to these flea markets, swap meets, garage sales, whatever, and I'm always buying these old wrenches, and you never know when you're going to use them for something, and that's what I used right here. I found this old wrench that happened to fit the bolt I was using, and I thought this would be a pretty cool little feature to have as the locking wrench, if you will. Locking bolt. It's going to hold this in place. All right, so that base swivels around. It's a little sticky, like I'd mentioned, but I was able to get rid of it and get it out, and that base swivels at full 360 degrees. All right, so now it's time to get the hinging mechanism. This is what's actually going to be, this part is going to be mounted to the bracket, the anvil bracket itself. And I'm starting out with some 5/8 by 2-inch flat bar stock. I got to make a couple tabs, so I'm starting out with a piece of about, I want to say it's about 9 inches long, and I got a couple of tabs I'm going to make out of both sides. I left it long because of this reason, so I can be able to work these tabs, drill the holes in them, and get everything I need to do. And then when I'm done, I'll just cut them to length. I just didn't want to cut them to length and be trying to deal with small pieces. I'd rather just have something long that I could handle and work with. So this hinging mechanism, this is something that I did on my swivel swing out bench, whatever you want to call it, that I had my welding table. It's a similar type of idea. It's a little bit different, but it's a similar thing. That's what I'm going to be using for this. That worked pretty good for that. I'm 250 pounds. I sit on that thing and it doesn't move at all. So this is what I decided to use. The Anvil is only 125 pounds, so I'm hoping I'm not going to have any issues with it. All right, so I'm just deburring right here. Now, I think it's this one right here. Yeah, I didn't get perfectly right in the center. I'm off a little bit, but hey, things happen. I don't think that's really going to be a big deal. I'm just kind of just deburring it. All right, everything is done. Now it's time to cut them to length. That Champion blade just cuts this stuff like butter. All right, so the idea is to have one on the top and one close near the bottom. All the while checking for square, be sure that I'm at 90 degrees, be sure everything is where it needs to be. I've got a piece of all thread here, and that was my initial plan, was to use all thread as part of the hinging post that goes through there. And you'll see here in a little bit that although the idea was good, I just was going to go with it, and then I just changed my mind. You'll see that here in a minute. First, I need to get all this stuff welded on here and get everything the way it needs to be. The important thing for me is this is a tight fit, and that piece of round tube is actually some DON drawn over mandrel, and that fits in there tight. But this is what I'm talking about. You saw the looseness that I had there, and I just couldn't have that being loose. It needed to be a tight fit, so I thought I'd just go ahead and make my own shaft. I'll make it a really tight fit, and so I'm trying my luck here for the first time on a lathe. It's going to be cutting some threads here. I've got a little bit of work to do. I got to bring it down to size. One side of the shaft is going to actually be a 3/4 10, and the other side is going to be 7/8 9. So I'm bringing the one side down to the right size before I cut the threads. A little bit of machine work, you know, not something I do every day. And I think I had to okay, so this here is me cutting the threads right here. This is the first run at it, and I believe this is the 3/4 10. It's worked out pretty good. I definitely had to do a little bit of cleanup on them, but it did work. May not be absolutely perfect, but it did work pretty good. And here you can see it spinning on right there. I did have to do a little bit of cleanup off camera, but I did get it eventually. And then I just have to cut a little bit of a shoulder for that 5/8 to sit in right here. All right, one side done, and now it's time to get to the other. Now this one's going to be a 7/8 9. The shaft is all ready to size, and I'm just going to go ahead and cut these threads in. You know, I did a little bit of research. I got a thread cutting tool, got the right size, but I've never done it before. Just learned off watching some videos and stuff, and like I said, I probably need a little bit more practice, but I ultimately got it and worked pretty good. All right, so with both sides done, now I need to bring the shaft itself to size. Now, I don't know. Maybe I should have done that first, then cut the threads. I was afraid of marring the shaft, while I was cutting the threads. So I elected to go this way. It was no problem. I didn't have any issues, but there's always a different way of doing things. But this is the way I elected to do it, and it worked out pretty good. So I got to bring this down. I forget how much I had to bring it down, but I made 4 or 5 passes right here, and then a finish pass, and I got it to where it's just going to be a tight fit, and that's what I was looking for. So the idea is to just have a tight fit in there, so there's no movement in that vertical part when you can imagine if it was a smaller diameter sitting inside that tube, you'd have a lot of play up and down. The idea is to keep this thing really tight, and that way it'll reduce the amount of play that's in there. So I got it to size, a little bit of emery paper right here, and a little bit of non-woven pad to give it a little bit of a polish. And I'm pretty happy with the way that turned out. Wasn't perfect, but not far from it, and it's going to serve its purpose. And it's such a tight fit that I definitely decided it was I better put a couple of grease circuits in there, and that's what I'm doing right here. All right, so I'm tapping this with, I got this a reversible tap head. It's an STM. Got it at KBC Tools. I got a couple of different sizes, and man, I gotta say, if you do a lot of tapping, those things are pretty cool. Tapmatic is another version of it, but I had to, this worked out best for me. For the amount of tapping that I do, those things are pretty cool. All right, here's a shaft, and it's fitting in there nice and tight. And I've got the bolts on either end, and there's no play in that, and that's just what I was hoping for right there. All right, so there it is, complete. So the next thing to do is to install, but that's about all I have time for in today's video. I hope you guys enjoyed watching this first part. Stay tuned for part 2. That's going to be the installation, and I've got some pretty cool footage of it actually being in use. So thanks for watching. Check out the website, JIMBO'sGarage.com, for torch lead holders, angle grinders, shirts, hats, miscellaneous merchandise. And I'll see you guys on the next video.
See you next time on Jimbo's Garage.